All right, component form of a vector. This is really straightforward. The way component form of a vector works, you know how we've been saying like two up, two down, blah, 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 blah. Well, the decision that gets made is like, hey, like, why don't we talk about like left versus right and then up versus down, kind of like X and Y. We use little angly brackets, and that is what we're about to talk about. There's these little angly brackets. And we use some value for left or right here, some value for up or down here. Um, so for instance, and we call the x1 the horizontal component, the y1 the vertical component. Um, if if x is positive, you move to the right. If x is negative, you move to the left. If y is positive, you move up. If y is negative, you move down. So the vector 4, -3, you start wherever, and then you're going to go to the right, 1, 2, 3, 4 to the right, 1, 2, 3 down, and boom, that's the vector you end up drawing. So let's go ahead and do these ones here. I'll just use purple. All right, for this one, this is 2 up, 1, 2, 3 to the right. So this is the x value is going to be +3 because you're moving right. The y value, when you're moving up, is going to be a +2. This is, whoop, maybe I should have color coded this thing off. This is green. This is pink. This vector is 3, 2. For this vector over here, we're going 1, 2 to the right. So that's +2 for the x value. And 1, 2, 3 down. Because we're going down, so this was a +2 because moved to the right. We're moving down 3, so it's -3. All right, vector C, starting at the tail. 1, 2, 3, 4, 5 to the left. Left is a negative, so -5. And then to get to the head, we have to go down 1. So this is -5 because you're going left 5, and -1 because you're going down 1. For D, D goes down 1, 2, 3, 4, 4 units down. So that's -4 for the vertical component. It doesn't move at all horizontally. So it's a 0. 0, -4. No horizontal movement. For E, this one moves 1, 1, 2 to the right. That right movement is +2. So the horizontal component is 2, and there's no vertical component there. Finally, let's draw some vectors. So 2, 6, I know x and y are both positive, so it's going to be moving, well, let's make a little arrow thing. It's going to be moving up, and it's going to be moving to the right, so it's going to be something like this. It means you want your tail down here. All right, tail down there. So this one is 1, 2 to the right. 1, 2, 3, 4, 5, 6 up. There it is. This is 6 up, 2 to the right. For this next one, oh, and this is your answer, just this guy right here. Oop, that's the vector answer. 0, -3. So I take the tail and I'm going to place it, I know, maybe I should write this here. This is 0 left or right. And -3 would be down 3, so 3 down. So I'm just going to put the tail somewhere where I can go 3 down. 1, 2, 3 down, no horizontal movement. Right, 3 down. That's the vector. -4, that's going to be 4 to the left. -2, that's going to be 2 down. Going to duplicate this vector here. So 4 left, so it's going to be moving left and down. So you should put your tail somewhere over here. We're going 2 down, 1, 2 down, 1, 2, 3, 4 to the left. Four left, 2 down. Okay. Finally, for this last one here, we are going 4 to the left again because it's negative. And this time the vertical component is positive, so we're going 2 up. So duplicate. Putting the tail here, we are going 1, 2, 3, 4 to the left, and then 1, 2 up. I should have put the tail further down. 2 up. There it is. All right. So there's drawing those vectors. That's how component form works. You have a horizontal and a vertical component. Now, we can kind of connect it to the coordinate plane by saying, hey, if you have 2 points, then you could find the vector that goes between them. The distance will be, if you have x1 and y1, x2 and y2, the distance is x2 minus x1. If it goes to the right, this number is positive because x2 will be a bigger number. If it goes to the left, the number will end up negative, which is what we want in component form. And then the vertical distance is y2 minus y1. Again, x1, y1 is the initial point, x2, y2 is the terminal point. So as an example, a vector has initial point negative 1, 2 and terminal point 4, 6. Write it in component form. So we have, this will be x1, comma y1. This will be x2, comma y2. We know that vector u should be equal to x2 minus, well, color code them, huh? X2 minus x1, comma, y2 minus y1. All right, x2 is 4. So 4 minus x1 is negative 1, so it'll be a plus 1. Minus a negative is plus. I guess I could write it out. I get lazy sometimes. There we go. Y2 is 6 minus y1 is 2. So vector u is 4 plus 1, 5. 6 minus 2 is 4. It should be the vector 5, 4. So that will be going 5 right, 4 up. And let's see if it is. So I'm going to plot the point negative 1, 2. That's right here. And then I'm going to plot the point 4, 6. So over 4, up 6. Initial point to the terminal point, this guy here. So let's see, is it 5 to the right? 1, 2, 3, 4, 5 to the right. 1, 2, 3, 4 up. Perfect. So that means we can feel real good about this answer here. Whoop, that's duplicate. Woo. Any moment now, a toddler will be walking in and making noise. So let's finish this video quickly. A vector W has initial point negative 3, negative 4 and component form 1, 7. What is W's terminal point? So this will be x1, which I use, no, it was green. Oh, no, it was x1, y1. And then we have its component form 1, 7. So it is the same setup here of the formula for of the vector x2 minus x1, y2 minus y1. We're looking for the terminal point. So the terminal point is the point x2 comma y2. That's what we're looking for. We know that u is equal to 1 comma 7. So we'll put that in 1 comma 7 is equal to, we don't know what x2 is, minus x1 is negative 3. So minus negative 3. Then we don't know what y2 is, but then y1 is negative 4, minus negative 4. So we have 1 comma 7 equal to x2 plus 3, y2 plus 4. And what you end up with is that this guy is equal to the horizontal component. So x2 plus 3 is equal to 1, i.e. x2 is equal to -2. And then over here, the vertical components need to be equal. So y2 plus 4 is equal to 7, i.e. y2 is equal to 3. So the terminal point x2 comma y2 should be, dun, 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 before the toddler walks in, should be -2 comma 3. That should be your terminal point. Let's find out. So we have point -3, -4. That's right here, initial point. We know the vector is the vector 1, 7. So it is going to go, this will go right, 1 right, 7 up. So 1 to the right, and then 1, 2, 3, 4, 5, 6, 7 up. Is this the point -2 comma 3? Is this it? It is. This is the point -2 comma 3, which is exactly what we got down there. All right, that's it for this section here. I will see you in the next video. Bye.